Hi, welcome to another mini lecture on pre-calculus. Today's topic is reference angles in radians, problem type 1. So let's review the issue. What is it that we are after? So we said we have this coordinate system. We have the x-axis and the y-axis, and this is the positive direction for us counterclockwise, and if we are going this clockwise direction, that's considered negative. We can measure our angles in a variety of ways, and two principal ones that are emphasized in your course are uh, the one where you measure the angles in degrees, that's the one probably you're most familiar with, and the one that is measuring angles in radians. So let's just quickly go over what was the radians. Radians, we had a circle, and it has some radius, and we take a string the same size as the radius laid on the circumference. It's the same thing as r, and then when we connect this thing to the origin, this is 1 radian. Well, it's a little bit perhaps strange looking unit, but that's the most natural unit we can consider. How many of these things fits in a circle? Well, like 0, 1, and you go 2 and 3 and 4, 5, and 6, and extra. So 6 and change is really 2 pi radians. So one circle is 2 pi radians, and that's 2 pi is just a number, 6.28, etc. And that's same as 360 degrees. We also said, well, there's another unit that doesn't show up in your textbook, but it shows up on your calculator, and that's called grads for people who like the metric system. Okay, when we do this in radians, we have to get our mind wrapped around the circle literally and figuratively, and the number pi shows up all over the place. We have to get used to that. So let's see, we start at here on x-axis is 0. By time we come half circle is at pi. By time we come back, it's 2 pi radians. And what is it here? It's pi over 2. And how about down here is 3 pi over 2. So everything has a pi kind of built into it. Doesn't have to be like if I say 1 radian, 1 radian if there's no pi in it, so 1 radian is somewhere around here. This is 1 radian. What is pi over 2? Well, what is pi? 3.14, etc. You divide it by 2 is 1.57. So instead of pi over 2, I could have written 1.57. Just pi over 2 looks a lot nicer than some strange looking decimal numbers. So pi shows up, doesn't have to show up. Well, what else? We could go, of course, in the negative direction. So that's going to be another issue that should be in front of our view, that if I have, here's the x-axis, start here 0 and minus pi over 2, minus pi, and minus 3 pi over 2, and by the time we make it back here is minus 2 pi. So now the direction is this clockwise, opposite of this one, which was counterclockwise. So in angle is given to us in radians, and what we want to find is reference angle. What was reference angle? We said if an angle is given to us which starts on the x-axis in the standard position and ends somewhere, it has a terminal side, the angle it makes with the horizontal is called reference angle. So if it was ending up in the second quadrant, then this would be our reference angle. If it had ended up in the third quadrant, then this would be our reference angle. And if it had ended up in the fourth quadrant, this would have been our reference angle. So these are all x-axis in each case. So reference one, quadrant 1, quadrant 2, quadrant 3, quadrant 4. This is how uh, we designate a reference angle. So reference angle is an acute angle, it's a positive acute angle that is between, if you are dealing with degrees, between 0 and 90 degrees. If you are dealing with radians, so reference angle of an angle theta, which is given to us in radians, is an angle theta prime, again in radians, made with horizontal, the horizontal line. So let's go ahead and practice to see how we deal with that. So suppose the angle that is given to us is 2 pi 15. Okay, the challenge is which one of these four cases is it? Is it in quadrant 1, 2, 3, 4, and so on? So we have to figure out 2 pi 15th versus, well, is it more than pi over 2 or less than pi over 2? What do you think? 2 pi over 15, is it less than or more than? You know, uh, since both of them have a pi, you can make it life a bit easier on yourself. Just just compare the fractions. Is 2/15 more than 1/2 or less than 1/2? Obviously, this is a lot smaller than 1/2. What does that mean? It means 2/15 ends up in the first quadrant. So this is, remember, it's 0. This is 1. Let me write instead of pi half, let me write 1/2 of pi. So the angle we are dealing with is 2/15 of pi. So both of them are multiples of pi. So I can compare the multiples, 1/2 versus 2/15. So 2/15 is a lot smaller than 1/2. It's like I'm ending up somewhere here. So I'm already in the first quadrant. Uh, the angle I'm after is the angle that's already given to me, 2 pi 15. That is the reference angle because the angle is in less than pi over 2 and it's positive. Okay, let's look at another one. 23 pi over 12. What is that? So let's wrap our head around that. 23 pi over 12. One way, so what you want to do is to pause this video and solve the problem for yourself and come back and compare your solution, and perhaps you might like whatever you have yourself better than what I explained here. But 23 pi over 12, so my angle is 23 pi over 12. We get a little bit of clue. So 23 close to 24. Why do I think about 24 pi over 12? Because if I had 24 pi over 12, that would have been just 2 pi. So this is a bit short of making it 2 pi, meaning an angle started here, went all the way around, came almost making a full circle, but not quite. We are at 23 pi 12. So how do we make sure? Uh, First of all, if you are already certain this is in the fourth quadrant, what is left to make the full circle, that is what the reference angle is. That is, if you take the full circle 2 pi and subtract from it 23 pi 12, well, what do? You take a common denominator. This is 1, this is 12. Common denominator is 12. Multiply that by 12, becomes 24 pi. And you subtract 23 pi from it. And all left is 1 pi over 12. So this angle is pi over 12. So our suspicion was correct. This is less than pi over 2, obviously. And our reference angle is going to be uh, pi over 12. So let's investigate this thing a little bit more. So we said this is, of course, 0. This is 1/2 of pi. This is 1 pi. This is 3/2 of pi. And this becomes 2 pi. So I wrote everything as a multiple of pi. So if I'm comparing 23 pi over 12, I can compare it versus 1/2. Is it more than 1/2 or less? Well, it's obviously more than that, because if you multiply, what you can do is like to simplify, you can put the pi's aside, divided by pi. Now you're deciding what's bigger, 23 over 12 or 1/2. It's just two fractions. You're comparing two fractions, and you multiply both of these things by 12. You see this is 23, this is 6. That's obviously bigger. How about versus pi? 23 pi, 23 12 pi. Is it larger than 1 pi? Well, yes, 23 over 12 is more than 1. How about 23 12 pi? Is it more than 3 half of pi? Well, yes, multiply both sides by 12. You see this is 23, this is 18. So by now, not only we passed the first one, but also second one, also third one, and then we are coming into final quarter. Well, is it more than 2 pi? Is it that 23 over 12 pi? Is it more than 2 pi? Have we passed the starting point? Well, if you multiply by 12, you see this is 23, that is 24. No, we have not passed 2 pi. So we have come somewhere close, but we didn't make it through 2 pi. So we are in the fourth quadrant. We haven't made a full circle yet. So our whatever is left is going to be our reference angle. So again, what we do is 2 pi minus the given angle 23 pi over 12, and out of that we got that pi over 12. Let's try another example. 11 pi over 12. So let's go through the same practice. So we have, starting at 0 pi, 1/2 of pi, 1 pi, 3/2 of pi, and 2 pi. So the question is, how do these things stack up against 11 pi over 12? Again, numbers that are given are actually friendly. 11 pi over 12 is close to what? It's close to 12 pi over 12, which is pi itself. So this is, from the looks of it, shy of half circle. 11 pi over 12 is slight short of 1 pi. So how do I talk about this? 11 12 of pi. We have passed through the first milestone, 1/2 pi. We have 11 12, obviously bigger than 1/2. How do I see that? Multiply by 12, you see 11 is more than 6. Of course, is 11 12 of pi more than 1 pi? Well, no, it isn't, because 11 12 is less than 1. So I haven't made it past this. So how do I figure out what is left? Easy. Half a circle is just pi. I am at 11 pi 12. I subtract to see what is left. Again, take a common denominator, multiply the first one by 12. Second one's 11 pi. When I subtract, I'm left with pi over 12. So this is easily pi over 12. Uh, and so on. So here's another example. This one is negative, minus 4 pi over 5, minus 4 pi over 5. So if you feel comfortable with the negative numbers, you can just go straight for the answer. If you feel a little bit like I feel, negative numbers, a little bit uncomfortable, what's negative? Uh, so you have two ways. One is to say, well, let's do everything about the unit circle in negative. So it's minus 1 pi 12 half. This is minus 1 pi. This is minus 3 halves of pi. This is minus 2 pi. Excuse me. Minus 2 pi. So what am I doing now? I am starting going this direction. Minus 4 pi over 5. Most of these problems are again friendly. This is close to what? It's close to 5 pi over 5. That is, we are slightly short of minus pi. That is, we have come all the way somewhere and we're stopping short of this at minus 4/5 of pi. Okay, if it was minus 5/5, well, that would be minus 1 pi. Minus 4/5 means I'm falling short. Whatever is here is our reference angle. So what we do is we subtract positives of these things. Pi minus 4 pi fifth. Take a common denominator. This becomes 5 pi, and that was 4 pi, and out comes pi fifth. So this becomes pi fifth. The reference angle is always positive. It's always between 0 and pi over 2. Option 2, say we feel dizzy with these negatives, we do what? So, okay, convert it to a coterminal angle, which is positive. How do I do that? Well, take the minus 4 pi over 5, add multiples of 2 pi to it until it becomes positive. So let's just add 2 pi to it to see. So I'm adding a positive 2 pi to this to see. So I'm really trying to figure out what is this. So I take a common denominator 5. This was minus 4. Now that multiplies by 5 becomes 10. So I have 6 pi over 5. 6 pi over 5. Then I can do it like I was doing in these previous problems. 6 pi over 5. I say, well, obviously we are past 0, past 1/2 pi, past pi because 6 over 5 is more than 1. Are we past 3/2 of pi? Now let's compare 6 pi over 5 versus 3/2 over pi. How do I compare it? Multiply by the common denominator, which is 10. This becomes 12 pi. This becomes 15 pi. So when I multiply by 10, I'm comparing 12 pi versus 15 pi. So that means 6 pi over 5 is smaller because this is smaller than that. So that means I'm not reaching 3/2 pi. I'm stopping somewhere here. So that is my angle. So what now? I say, okay, 6 pi over 5. Let's subtract the pi from it, minus pi. I subtract how? Take a common denominator. This is 6 pi. I have to multiply this thing by 5. And then I'm left with what? Pi over 5 which is what we had here, pi over 5. Two ways we got the same answer. Minus 8 pi over 9. So again, we are starting from here, 0 minus 1 half pi, and this is minus 1 pi. This is coming to what angle? It is short of uh, uh, that straight line minus pi. We are stopping at minus 8 pi over 9. Okay, why do I know I'm stopped here? I stop here because 8 is smaller than 9, so I'm less than 1. I haven't made it to minus 1 pi. I'm falling short of that, and so whatever is left is my reference angle. How do I figure it out? I write pi minus 8 pi over 9. Take a common denominator, which means write this as 9 pi over 9 minus 8 pi over 9, and out comes pi over 9. So this is pi over 9. Do we have another one? Yes, it looks like we have another one. Good. Minus 7 pi 16. Again, strong recommendation. Pause the video, figure it out for yourself, and then come back and compare what you have with this. So let's just stay comfortable with negative numbers. So minus 1 half pi, minus pi, minus 3 halves pi, minus 7 pi over 5. Question, where do I stop? So I'm going in the negative direction, obviously not here, so I essentially have to press the buzzer. Where do I stop? So it's quadrant 1, 2, 3, 4. Main question again, let me insist, stop the video and figure out for yourself and come back. Minus 7 pi. 7 is larger than 5. Is that right? 7 is larger than 5. So we have passed, this is minus 1 pi. This is 7/5 of pi. 7/5 is more than 1. So I passed this. I'm coming into second quadrant. Do I also pass through this vertical minus 3 half pi? So the question is minus 7 pi over 5 and minus 3 half pi. When I am comparing these two, how do I compare? Multiply by the common denominator, which is 10. This becomes minus 14 pi, and then this becomes minus 15 pi, right? So 14 is short of 15, so I'm stopping here. I'm stopping in second quadrant. This is minus 7 pi over 5. Okay, question is, well, what is this angle? What is that angle? So I take 7 pi over 5, subtract the pi from it. So I take a common denominator, 7 pi, and then how do I make a common denominator? This becomes, of course, 5 pi over 5. Multiply and divide by 5. So this becomes 2 pi over 5. My extra angle here is 2 pi over 5. Okay, so we had a bit of difficulty because we have to get used to this business of angles being measured in terms of pi. Once again, most of the problem you see here, there is a pi showing up in the measure of the angle. It doesn't have to be like that. So if you come across 1 radian, you might get confused as to, well, where did my pi go? Well, comfortable angles like multiples of pi will have a pi in them. So if you want to be a little bit dizzy about what where is my pi in 1 radian. Here, come back and think about, well, this pi over 2 is really 1.57. That's just a number, 1.57. The same way, 1 radian is just a number. Again, those of you who want a little bit extra, here's a problem, not for grade, not for uh, anything, just in case you're curious. If I have an angle that is 10,000 radians, some ridiculously large number, 10,000 radians, what is the reference angle of this? Huh? So we need to come up with some sort of a mechanism to find a reference angle that's going to be a little bit more uh, congealed and certain that just trying quadrant by quadrant and just saying, well, I passed this one, I passed that one, I passed that one. With an angle that's like 10,000, well, by the time you go through all these quadrants and circles and such, a month has passed and then you're still trying to figure out where you are if you have not made a mistake and such. So as a mathematical practice, for those of you who might be interested, if I have a very large number and they ask me what's the reference angle of it and everything done in radians, how do I figure it out? Okay, so that was just something extra. Going back to this, what we learned is you can take the unit circle, label it as 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. Uh, Here I have to have a 2 pi. If your angle is positive, you try to figure out which quadrant you're in and then subtract accordingly to figure out your reference angle. With the negative angles, you have two ways. You can add 2 pi's to it until it becomes positive and process that. Or if you feel comfortable with negative angles, then you perform that operation. Okay, until next lecture, good luck and God bless.